Before starting the example number 2, once read yesterday's class. What is polar plot? How to draw the polar plots? What are the key points in the polar plot? For 5 minutes. All of you read the yesterday's key points. Can anyone tell the first step in the polar plot? What's the first step? What's the first step in polar plots? Yes. Sumant gave some reply. Replace S by J omega. Good. So what do you call replacing S by J omega? It is called sinusoidal transfer function. It's very important even for drawing board plots. So remember this point. If you replace S by J omega, it is called sinusoidal transfer function. That is, the input is sine wave, and the transfer function is called sinusoidal transfer function. So we'll replace S by J omega to get the sinusoidal transfer function. Substitute is equal to J omega. Substitute s equal to j omega, it will be 1 by j omega into 1 plus j omega t, right? So next step, so next step, rationalize the sinusoidal transfer function, isn't it? So one give some reply. Yeah, rationalize the Sai Likita. Give some reply. Rationalize the transfer function. Very good. So how do you rationalize g of j omega? It is your sinusoidal transfer function is equal to 1 minus j omega t by j omega into 1 plus j omega t multiplied by 1 minus j omega t, right? Then separate the real terms and imaginary terms. So if you separate the terms to it, will be minus t by 1 plus omega square t square minus j into 1 by omega into 1 plus omega square t square. So check this function. Did you get the answer or not? Did you get this function, all of you? The real term will be minus t by 1 plus omega square t square minus j into 1 by omega into 1 plus omega square t square. Very simple. So 1 by multiplied by this term will be 1 plus omega square t square by 1 by j omega. So this could be the imaginary term, and this imaginary term j omega gets cancelled. It will be minus t by 1 plus omega square t square. Very simple. Very simple equation. Simple mathematics. So next step. Can anyone tell next step? So we substituted s equal j omega to get the sinusoidal transfer function. We rationalized the function and we separated the terms, real terms and imaginary terms. What's the next step? Any answers? Any response? Next step. Any response? Yeah, I got some response. Find the first point and end point, g of j0 and g of j infinity. Yeah, I got response from Sumant and Lakshmi Pranavi. Substitute with omega equal to 0 and omega equal to infinity. Very good response. So let us find out the points, first point and end point by substituting omega equal to 0. Let me put in this way. Limit omega tends to 0. G of j omega is equal to g of j0, which is equal to it is minus t by 1 plus omega square t square. So omega will be 0 here, minus t by 1. So the real term will be minus t here, and minus j into omega value is 0. Here also 0. 1 plus 0, it is 1. 1 into 0. So 1 by 0, it is j infinity. Right. So this is your first point. Right. Next point, limit omega tends to infinity, g of j omega, which will be g of j infinity, which is equal to, well, let us substitute the omega tends to infinity. So what's the value when omega tends to infinity? The real value 1 plus infinity almost, right? It is infinity only, right? So infinity minus t by infinity. So it would be minus 0. So you always keep the sign for real terms as well as imaginary terms, right? Minus j into again omega tends to infinity. 1 plus infinity square, it is again infinity. Infinity multiplied by infinity, it is infinity only. So 1 by infinity is always 0. Right? This is the end point or last point of the polar plot. Right? Okay. So let us draw the polar plot for this equation. So first we need to draw, sorry, assume this is a real axis. This is imaginary axis, 0 degrees, might be minus 90 degrees, minus 180 degrees, minus 270 degrees. Now what's the first point? The value is, the real value is minus t. Minus t means it is on the negative real axis, that is left side of the j omega axis. So let this point, let us say this point, I'll use another color for this. Let this point will be t, right? This is the t value or minus t value. Let me say it is a minus t value. And what is the imaginary value? It is minus j infinity. It is minus t and minus infinity. Where do you find these negative values, real and imaginary values? In the third quadrant, right? The third quadrant, you have negative values. Right? Both real and imaginary values negative, right? So your first point will be in the third quadrant and also the last point also in the third quadrant, right? But if you look at the imaginary value, it is minus j infinity. So it is somewhere like this, right? I don't know. I'll draw a asymptote line for this. Minus t minus j infinity means it is somewhere like this. And the last point would be minus c minus 0. This will be minus 0 minus j0 and this will be your t here, the length. So it must reach the point like this. So it started at, somewhere with length minus t and infinity. So, so in this case, you don't get any semicircle, but your point, because of this infinity, you are getting some parallel line and it is reaching the zero like this, right? So since we don't have the first point in this, obviously you can show with the asymptote line. Recall your root locus technique. Whenever one branch is terminating on infinity, we will draw one asymptote line and your root locus branch will follow that line. So similarly here also, you should have a point at minus t and imaginary term is always infinity, right? So I'll make it clear. So it is somewhere like this, right? Somewhere like this. So this is how you can draw the polar plot for a given example number 2. So if you have any questions, you can ask. If you have any questions, you can ask. Otherwise, we'll move to the next example. Example number 3. This is one type of model in polar plots. In yesterday's class, it is both points are in the same quadrant, but we know the starting and ending points. That's why we got semicircle. But in this case, we don't know the first point at a particular position, right? So that's why we got the curve like this. So we have a point at infinity. So that's why you got the curve like this. So if you know the point, definitely you'll get the semicircle. So that's a clarification about yesterday's example and today's example, right? Let us move on to the example number 3. Very simple drawing, this one, polar plots. Example number 3. So g of s is draw the polar plot for g of s is equal to 1 by 1 plus. We always remember your function should be in time constant form. So here it is in time constant form. right? So this is your function. We should draw the polar plot for this function. So that's the first step. So all of you substitute s equal to j omega to get sinusoidal transfer function. Transfer function. Right. So your function would be g of j omega is equal to 1 by 1 plus j omega into 1 plus j 2 omega. Right. So here we have the numerical values, right? So it's the next step after rationalizing. So rationalize, after substituting s equal to j omega, rationalize g of j omega. So it will be g of j omega is equal to 1 minus j omega multiplied by 1 minus j 2 omega by 1 plus j omega into 1 plus j 2 omega multiplied by 1 minus j omega into 1 minus j 2 omega. So separate the real terms and imaginary terms quickly. Tell me the answer. Quickly do it. So the next step would be g of j omega is equal to. So in the numerator, it will be 1 minus j 2 omega minus j omega plus j square 2 omega square, I think 1 into 1 minus j omega plus j square omega square into 2, right? By, so it would be 1 plus b into j square 1 minus b square, j square would be, it will be 1 plus omega square, and also next one 1 plus 4 omega square, right? Okay. So this would be in the numerator, it will be 1 plus j square would be minus 1, no? So it is, I'll just writing 1 minus 2 omega square minus 3 omega by 1 plus omega square into 1 plus 4 omega square. Let me see, someone did it. No. Okay. So after rearranging the terms, it would be g of j omega equal to the real term will be 1 minus 2 omega square by 1 plus omega square multiplied by 1 plus 4 omega square minus j into 3 omega by 1 plus omega square into 1 plus 4 omega square. So we separated the real term and also imaginary term. Next step, we need to find out the first point and last point. That is when omega equal to 0, our or omega tends to 0, your g of j0 would be is equal to this is 0, you got 1 in the numerator, this is also 0 and this is also 0, you got the value as 1 here, the real value is 1 minus j into this is 0, 1 plus 0, 1, 1 plus 0, 1, and this would be j into 0, so it is j0. So this is your first point, 1 minus j0. Very good. When omega tends to infinity, or g of j infinity would be, yeah. So what's the value here? Can you tell the value now? Substituting infinity. Anyone tell the answer? Substituting infinity. Can anyone tell the answer? The last point. Very critical point in the polar plot, substituting infinity values. No, don't. Very simple. In the numerator, 1 minus 2 omega square, no? So if the value is almost large, you will get minus omega square in the numerator, and in the denominator it will be omega square multiplied by omega square, right? And this will be the equation in the real value, right? 1 minus 2 omega square. Subtracting infinity with 1, it is again minus omega square. So it will be cancelled. You will get minus 1 by infinity. It is minus 0. So this is how you can do it. So your value will be minus 0. This is the critical point in these polar plots. Substituting infinity value, observe the omega terms and follow the procedure. Let us look at this is real term, right? Real term. I'll write here. Right. So imaginary term, it will be minus j, I'll keep as it is, and it would be 3 into omega by omega square into omega square. So we'll get here, it will be again 1 by infinity, it is 0, right? So it is minus 0 and minus j0. So this is your first point. And this is your endpoint, right? Now let us draw the polar plot for this. This is your real 0 degrees and minus 90 degrees. This is imaginary minus 180 degrees minus 270 degrees. I got something in chat box, I thought. Yeah. Sumant gave some answer. It is 0 minus j0. It's wrong, Sumant. You should consider negative value. It is 1 minus 2 omega square. And Kiran Kumar also said minus 2 plus j0. Sorry, both are wrong answers. Anyway, I gave some clarification and substituting the infinity. Let me show you once. So it is 1 minus 2 omega square. If omega is infinity, right? So this is the bigger value, larger value, this point, right? So this would be this point will be larger, right? So subtracting 1 with larger value, it's a negative value only. So that's why I put here minus omega square, right? And here also adding 1 for bigger value would be omega square. Here also adding, multiplying with 4 and adding 1 also bigger value. So this is how you have to calculate the real value. So similarly, in the imaginary term, it is minus j, I kept it as it is, and multiplied by 3 with bigger value, again it is omega only, and adding the bigger value for omega, it would be omega square only. So obviously you can cancel these terms, and if you multiply with again omega to omega square, it's also bigger value. So this is how you have to find out the points. Right? Anyway, you gave some response. So generally, most of the students done the mistake in finding the infinity value, that is end point. Okay. So let us talk about the first point and the last point. The first point, 1 minus j0. So the real value is 1 here, and the imaginary value is negative value. So it would be a third quadrant phasor. So it is, I'll take, yeah. So this would be the point. The value is here 1. Right? So it's an endpoint. Endpoint is minus 0 minus j0. So it is in the fourth quadrant, right? So this is in fourth quadrant, and this is in, sorry, this is in third quadrant. The endpoint would be in third quadrant, and the first point will be in the fourth quadrant, right? So what happens if we have a first point in the uh, fourth quadrant and second point or end point is in the another quadrant, so it must cross the imaginary axis, right? Definitely it must cross the imaginary axis. So in this case we should find out the point of intersection with j omega axis, since this point or this polar plot must cross this point here, right? If you substitute the values till this point, it must um, cross this imaginary value. And the, what is the end point again? It goes like this. We know the starting point of this quadrant, third quadrant, this one. And the last point would be again it is minus 0, j0. So it should reach like this, right? So I'm approximately drawing the polar plots. So it would be like this. Okay. So let us look at the crossover point, right? So I'll write here this plot does not cross the real axis, isn't it? Doesn't cross the real axis, but it crosses the imaginary axis. So at the frequency given by the solution of, so what's the term? So on the imaginary axis, what happens? Your real value would be 0. So what's the real value? The real value will be 1 minus 2 omega square by 1 plus omega square into 1 plus 4 omega square, right? This would be 0, right? The real term will be 0. So here you will get 1 minus 2 omega square is equal to 0, or omega would be 1 by root 2, right? So this is the cross section point, right? Now how do you find the imaginary value? Substitute this omega value in the imaginary term. So here I will write the value of j omega, and real term is 0 at this frequency is minus j into 3 omega by 1 plus omega square into 1 plus 4 omega square at omega equal to 1 by root 2, right? So substitute omega equal to 1 by root 2 and quickly tell me the answer. After substituting omega equal to 1 by root 2, So this is the point, imaginary point, right? So after substituting the real value is equal to 0, you'll get some frequency. At this frequency, your real value would be 0. At this frequency, this real value is 0. So now substitute this frequency in your imaginary point. So real value would be 0 here. So substituting at omega equal to 1 by root 2, it would be the value. Any answers? No. It would be minus j 0.471, right? So this is the crossover point. So your value, this point, the crossing point is minus j 0.471, right? So it would be, the crossing point is minus 4.1. This is your ending point. Now what's the starting point here? Is 0 comma minus j 0.471. As I mentioned, if you have same points, same quadrant, you will get the polar plot is like this. Okay. So this, at this point you have omega value is equal to 1 by root 2. So I can say even more, the length is 0.471. You can even draw it on the graph sheet. You get perfect shape, right? So the end point, the first point would be minus 1 minus j0. We should write it at omega equal to 0. And the last point would be minus 0 minus j0, right? At omega estimate. Okay. So if you have any questions, you can ask till this point. So if you don't have any questions, let us move on to the next example. Example number 4. So You all try this example number 4 quickly. Your g of s is equal to 1 by s into 1 plus s into 1 plus 2s. So it is in the time constant form, no need to convert into time constant form. Right? And then substitute s equal to j omega to get the sinusoidal transfer function. G of j omega equal to 1 by j omega into 1 plus j omega multiplied by 1 plus j2 omega. We got the sinusoidal transfer function. Then rationalize the sinusoidal transfer function. J of j omega equal to 1 minus j omega multiplied by 1 minus j2 omega by j omega multiplied by 1 plus j omega multiplied by 1 plus j2 omega multiplied by 1 minus j omega multiplied by 1 minus j2 omega, right? So now separate the terms. Quickly do it. If you separate the terms, you'll get g of j omega would be minus 3 by 1 plus omega square multiplied by 1 plus 4 omega square minus j into 1 minus 2 omega square by omega into 1 plus omega square 1 plus 4 omega square. So I separated the terms. The next step would be, say once you know the procedure, you can do it quickly. When omega equal to 0, your j of j0 would be, so here it is 0, 0, it is minus 3, minus j, now it is 0, and of course this 0, 0, it is 1 by 0, so it will be infinity. So when omega equal to infinity, your endpoint j infinity would be, here in the numerator we don't have any omegas, so it would be minus 0, then minus j into, so as I mentioned earlier in the previous example, 1 minus 2 into omega square, so it would be a negative term, so negative negative becomes positive, and omega square gets cancelled, and you have 1 by infinity, it is plus j0. So this is how you can find the first point and the last point. Look at the quadrants. First point, end point. So it's a quadrant. The first point minus 3 minus j infinity. It is in third quadrant, and the last point would be in, this is third quadrant, and this would be minus 0, that is real value 0, and this would be second quadrant. Right? So definitely let us draw this here, real, imaginary, j omega 0 degrees, minus 90 degrees, minus 180 degrees, minus 270 degrees. So the end point would be crossing the real axis, right? So in this case, it is a real axis. So we have to find out the crossover point, real axis crossover point. Let us find out the crossover point, the frequency, at which the plot crosses the real axis is 1 minus 2 omega square by, oh sorry, let us move on, by omega into 1 plus omega square, 1 plus 4 into omega square is equal to 0. So again, you will get omega equal to 1 by root 2 and substitute the value of the real axis g of j omega, when imaginary term is equal to 0, is minus 0.666. So if you do it, you'll get it. I'll denote that minus 0.66. It is somewhere here. So this would be the length. I'll put it here. This length would be minus 0.66 and crossing point, and this would be the end point, minus 0 plus j0 at omega equal to infinity. And what's the first point? It is minus 3, no? So if it is 0.6, it is 1, 2, 3, somewhere here. So let us denote this as minus 3. And since your imaginary value is at infinity, draw the asymptote line at this real axis. So it would something like this, starts at infinity and reaching this point. Sorry. So draw the smooth curve. Sorry. Is somewhere. So it is something like this, right? To go up. So the ending point would be somewhere here. So you can draw like this. So it reaches like this, and from this point it is same quadrant as I mentioned. You can draw a semicircle here, right? So this is how you can draw the polar plot, right? In this case, so it's a crossover point minus 0.66. And this would be minus 3. Okay, so the point will be minus 3 minus j infinity at omega is equal to 0, right? Right. So draw extension for this. So since I'm drawing it to whiteboard, you can extend this. Here's the graph sheet for this also. It's very easy to draw the smooth curve from first point to the last point, right? So this is how you can draw the polar pairs. So these are the models. Example 1, 2, 3, 4. These are the 4 models in the polar pair. One is crossing, one is within the same quadrant, one is crossing the real axis, and another one is crossing the imaginary axis, and one is reaching the infinity. One point, your point is at the reaching the infinity. So inverse polar plots, let us finish this topic. Very simple. Inverse polar plots. Inverse polar plots. Very simple. The inverse polar plot of g of j omega is a graph of 1 by g of j omega as a function of omega. Very simple. The inverse polar plot of g of j omega is a graph of 1 by g of j omega as a function omega, right? So for example, very simple understanding, for example, you have g of j omega is equal to 1 by 1 plus j omega t, your first example. So it would be 1 by inverse polar plot is nothing but 1 by g of j omega. So this could be g inverse of j omega, which is equal to 1 plus j omega t, right? So inverse polar plot g inverse of j omega is equal to, so it's a magnitude, it is 1 plus omega square t square at an angle of tan inverse omega t. So if you draw it quickly, a polar plot is a parallel line, isn't it? It is at real axis. It is 1.0 here, and omega equal to 0. And here omega tends to infinity, you have parallel line. This would be minus 90 degrees, 0 degrees, minus 180 degrees, minus 270 degrees, and this is j omega. You'll get a parallel line, right? So when omega increasing, okay, you have a constant magnitude and present. So this is about polar plots. If you have any doubt, you can ask me the next class. And for mid-one syllabus, till polar plots, so you definitely get one root locus plot, one roots criteria, and one signal flow graph. Okay, I hope you understood the concept. So you can leave the meeting.